you observe this, discuss the continuity of the function f. Discuss the continuity of the function f, where f is defined like this. Now, if you observe, again 5 case problem came. This is going to be lengthy. 5 case problem. Okay. We need to discuss continuity of the given function. Okay. To discuss the continuity of the function, first we need to know domain of this function. Can you say what is domain of this function? What is domain of this function? Is this function is defined for every real number? I'll check. Suppose x equal to 100 is there. Then which function to choose? 100. 100 is a number which is greater than 1. So I need to choose the third function. Okay. X equal to 1 is there. Then which function to choose? 1. Here, look here. X equal to 1. At the time we need to choose second function. Suppose x equal to 0 is given. Then which function to choose? X equal to 0. 0 is there in this zone. In this interval 0 is there. At the time I need to choose second function. Okay, x value is minus 1. Which function to choose? You look here, equality symbol is there. When x equal to minus 1, I need to choose this function. Okay, when x equal to minus 100 is there, then at that time which function to choose? Minus 100. Minus 100 is less than 1. So I need to choose this minus 2, first function. So what is the domain of this function? Domain of this function is all real numbers. So first conclusion, I came to know that domain of this function is all real numbers. Okay, I need to check the continuity of the function on its entire real number. You observe this function is varying at 2 points. Look here, minus 1, 1. So I'll mark those 2 points on the number line. This function is varying at 2 points, minus 1, 1. So I am going to do this problem in how many cases? Total 5 cases you will get. What is case 1? I'll check the continuity whenever x value is less than 1. That means in this zone, I'll check the continuity of the function. This is case 1. What is case 2? I'll check the continuity of the function at minus 1. I'll check continuity in this zone. This is case 2. Next, case 3. I'll check the continuity when x value is in between minus 1 and plus 1. I think this is not properly visible. Right, I'll write here. This is minus 1. This number is minus 1. This number is plus 1. Okay, I'll check the continuity when x value is in between minus 1 and plus 1. I'll take this as case 3. Case 4. What is case 4? I'll check the continuity of the function at x equal to 1. What is case 5? I'll check the continuity of the function when x value is greater than 1. So this is case 4 and this is case 5. I need to check the continuity of this function. For that, I came to know that domain of this function is all real numbers. As the domain of the function is all real numbers and this function is varying at 2 points, minus 1 and plus 1, I marked minus 1 plus 1 on the number line. And I came to know that I need to do this problem in 5 cases. Case 1 is x equal to a is less than minus 1. Case 2 is at x equal to minus 1. Case 3 is when x value is in between minus 1 and plus 1. Case 4 is at x equal to 1. Case 5 is when x is greater than 1. This problem is going to be a little lengthy. Have patience and let's start the solution. Case 1. What is case 1? I need to check the continuity of the function at x equal to a. What is case 1? Whenever a value is less than minus 1. Okay, a value is less than minus 1. Okay, how to check the continuity? How to check the continuity? What is the hero of this story? In this limits, what is the hero of this story? Limit x approaches to a, f of x equal to f of a. Limit x approaches to a, f of x equal to f of a. Then we say that function is continuous at x equal to a. So for that, what I'll do? I'll calculate limit x tends to a, f of x. Next, I'll calculate f of a. If both are equal, then I can say that function is continuous at x equal to a. So what I'll do? First, I'll calculate limit x tends to a, f of x. Okay, calculate limit x approaches to a, f of x. Okay, that equal to limit x approaches to a. What x approaches to a value less than minus 1. When a value less than minus 1, which function to choose? I need to choose this function minus 2. So here what is f of x? F of x is minus 2 because a value is less than minus 1. So now I need to calculate this limit. How to calculate this limit? In limits chapter, for any problem, first we try by direct method. What is direct method? In the given function, wherever x is there, we will write a, Actually, in the given function, x value is not there. So what is its answer? Its answer is minus 2 only. So when I calculated limit extends to a f of x, I got it as minus 2. Now I'll calculate f of a. Okay, f of a. F of a. Calculate f of a. To calculate f of a, we need to decide which function is here. To choose which function here, what is a? A is less than minus 1. When a is less than minus 1, f of x is minus 2 only. So here f of x is minus 2. What is f of a? What is f of a? Here in place of x, here a is there. In the given function also, wherever x is there, there we will write a. But in the given function, x is not there. So what is f of a? F of a is minus 2. So f of a is minus 2. When I calculate this value, I got it as minus 2. I got f of a also minus 2. So what I can say? I can say that these two are equal, right? So I'll write that one. Therefore, what I got? Therefore, see here, this value is minus 2. This value is also minus 2. I can say that these two are equal. See here, limit extends to a f of x equal to f of a. Limit extends to a f of x equal to f of a. Then what I can say? I can say like this. Therefore, f of x is continuous at x equal to a whenever a value is less than minus 1. Okay. So I checked the continuity in this first interval. In first case, I came to know that this function is continuous at x equal to a whenever a value is less than minus 1. Okay. So I need to check the continuity at this point at minus 1. Case 2. Okay, right. Case 2. In this zone, I checked the continuity. I came to know that it is continuous whenever a value is less than minus 1. Now I'll check the continuity at minus 1. Okay. Case 2. What is case 2? At x equal to a. What is a value here? A value is minus 1. I am checking continuity at x equal to minus 1. When we say f of x is continuous at x equal to minus 1. When we say function is continuous at x equal to minus 1. Yes. By this time, you must thorough with these things. Limit x approaches to minus 1. F of x equal to f of minus 1. When this holds good, then we say that this function is continuous at x equal to minus 1. Okay. So for that, what I'll do, I'll calculate this value. To calculate this value, we have a problem here. What is that problem? I'll discuss. Repeatedly saying again and again, I am feeling bored. By this time, you must understand this point. Okay. Limit x approaches to minus 1, f of x. Okay. Limit x approaches to minus 1. X approaches to minus 1 means all x values are slightly less than minus 1 or all x values are slightly greater than minus 1 but not minus 1. So what I am trying to say, x approaches to minus 1 means there is a chance that x values are less than minus 1. When x values are less than minus 1, we need to choose this function minus 2. When x values are greater than minus 1, look here, minus 1 less than x means x greater than minus 1 only. When x values are greater than minus 1, I need to choose the function 2x. So here, which function to choose? Here, both the functions are eligible to write. So we cannot write both the functions here. So to avoid this confusion, I'll calculate left hand limit and right hand limit. Okay, what we concluded? To calculate this, I'm going with left hand limit calculation as well as right hand limit. Okay, left hand limit calculation. Left hand limit. Limit x approaches to minus 1 from left. X approaches to minus 1 from left, f of x. That means limit x approaches to minus 1 from left. Here what the point is, x approaches to minus 1 from left means all x values are less than minus 1. When x values are less than minus 1, which function to choose? We need to choose this function minus 2, right? So here what is f of x here? F of x is minus 2, alright, that minus 2. Now what to do? I need to calculate this limit. How we will calculate this limit? By direct method. What is the direct method? This is the function. Wherever x is there, there you write minus 1. But actually in this given function x is not there. So what will be its limit? It is minus 2. So I calculated left hand limit, I got it as a -2. Okay, now to calculate this, I'll calculate a right hand limit. Okay, calculate a right hand limit. Okay, limit x approaches to -1 from right, f of x equal to limit x approaches to -1 from right. X approaches to -1 from right means all x values are greater than -1. When x values are greater than -1, look here. When x values are greater than -1, which function to choose? This is the function 2x, right? The function is 2x. So what I'll do now? How I need to calculate this? How to calculate this? In the given function, wherever x is there you write -1. So what you will get, that is 2 into -1. To calculate limit of this, we'll try by direct method. What is direct method? In the given function, wherever x is there you write -1. 2 into -1 is -2. Okay. So what happened here? Left hand limit I calculated, I got -2. Right hand limit I calculated, it is -2. Left hand limit is same as right hand limit. So what I'll say? Therefore, I'll write here left hand limit equal to right hand limit. When left hand limit equal to right hand limit, we say that therefore limit x approaches to -1, f of x equal to -1. I calculated this value, I got it as -1. Now what to calculate? I need to calculate f of -1. Look here f of -1 I want to calculate. Now x value is -1. When x value is -1, what is the function? Function is -2. So what I can write here? Directly I can write f of -1. 1 minute. F of -1. F of -1 is what? F of -1 is, sorry, it's a small mistake. I written a mistake. Please look here. What is left hand limit here? What is left hand limit? -2. What is right hand limit? Right hand limit is -2. So limit extends to -1. F of x is what? -2, right? This equal to -2. Okay. I am calculating this f of -1. What I got when x is -1? F of -1 is -2. So this is -2. So what I got here? I got that limit extends to -1. Look here, limit extends to -1. F of x is -2. F of -1 also -2. So what I can say from this? When this statement is true, I can say that f of x is continuous at x equal to -1, right? Therefore, f of x is continuous. F of x is continuous at x equal to a is -1. I am checking the continuity of the function. Look here, case 1, it is continuous at -1. I checked this at -1. What I got at -1? At -1 I got that this is continuous function. So case 2, at case 2 also this is continuous. So this function is continuous at case 2 also. Now I need to check the continuity of the function in case 3. What is case 3? When x value lies in between -1 and +1. Okay, we'll move to case 3. For that, what are the things needed? We'll carry forward all those things. Okay, we are doing case 3. Okay, case 3. What is case 3? At x equal to a. What is a? A value is in between -1 and +1. I'll write here. What is a? -1 less than a less than 1. So what to check? I need to check the continuity of the function at x equal to a. When we say function is continuous at x equal to a, limit extends to a, f of x equal to f of a, then we say that function is continuous at x equal to a. So I'll calculate that. Limit x approaches to a, f of x. I'll calculate this. Limit x approaches to a. X approaches to a means here what is a? A is in between -1 and +1. When a is in between -1 and +1, which function to choose? We need to choose this function 2x. So here I'll write 2x. Okay, that equal to. Now I need to calculate this. How to calculate this? Wherever direct method. How I'll calculate this? By direct method. What is direct method? In the given function, wherever x is there you write a value. So what you will get? In place of x, if I write a, this will become 2a. So I'll calculate f of a now. What is f of a? What is a here? What is a here? A is in this zone. Na? So to calculate f of a, we need to choose this function. So f of x is 2x, f of a is 2a. F of a is 2a. So what I got? I calculated this value, I got 2a. F of a also 2a. So what I can say? Therefore, limit x approaches to a, f of x equal to f of a. So therefore, f of x is continuous at x equal to a whenever a value is in between -1 and +1. So I checked the continuity of the function in case 3. I got that it is continuous. Okay. Now case 4. I'll check the continuity of the function at x equal to 1. Check the continuity of the function. I'll take this function along with us. I am checking the continuity at 1. Okay. This is case 4. Okay. Case 4. Okay. At x equal to a. What is a value here? A value is 1. What I need to check? I need to check the continuity of the function at x equal to 1. When we say f of x is continuous at x equal to 1, very simple. Limit x approaches to 1, f of x equal to f of 1. Limit x approaches to 1, f of x equal to f of 1. Then we say that function is continuous at x equal to 1. So here I will calculate this. Limit x tends to 1, f of x. To calculate limit x tends to 1 f of x, we have a problem. X approaches to 1 means there is a chance that x value less than 1, x value greater than 1. When x value less than 1, we need to choose this function. When x value greater than 1, we need to choose this function. So to calculate limit x tends to 1 f of x, it is important you need to know that we need to calculate left hand limit as well as right hand limit. So what I'll do, I'll calculate left hand limit. Okay, limit x approaches to 1 from left, f of x, that equal to limit x approaches to 1 from left, x approaches to 1 from left, f of x. Which function to choose? X approaches to 1 from left means all x values are less than 1, right? When x values are less than 1, which function to choose? This one. This is 2x. So I'll write here 2x. Now I need to calculate this. How to calculate this? By direct method. Wherever the function is there, in that function you write 1. That is direct method. Put x equal to 1 in this. So what you will get? 2 into 1. That is 2 1. Now I'll calculate right hand limit. How to calculate right hand limit? Limit x approaches to 1 from right, f of x equal to limit x approaches to 1 from right. X approaches to 1 from right means all x values are greater than 1. When x values are greater than 1, which function to choose? That is 2. So here function is 2. Now I need to calculate this. How to calculate this? By direct method. What is direct method? In the given function, wherever x is there you write 1. Actually this is constant only. So limit x tends to 1 plus f of x is what? That is 2 only. So you will get 2 only. So what happened here? Left hand limit is 2. Right hand limit is also 2. When left hand limit is same as right hand limit, then what we say? Limit of this exists and this limit value equal to 2. That only I'll write. Left hand limit equal to right hand limit. Therefore limit x approaches to 1, f of x. What I got this value as 2. Now what I need? I need f of 1. F of 1. In place of x here, what is there? In place of x here, 1 is there. So when x equal to 1, which function to choose? We need to choose 2x. So here f of x is 2x. F of 1 is 2 into 1. That is 2 only. So f of 1. So f of 1 is 2. Look here. I calculated this. I got 2. I calculated f of 1. That is also 2. So can I say that these two are equal? Yes, we can say. So what happens here? Limit x tends to 1, f of x equal to f of 1. Therefore, f of x is continuous at x equal to a value is 1. I checked continuity at 1. I got that it is continuous function. So till now, whatever the 4 cases I did, in all 4 cases, I came to know that this is continuous function. Only one more is remaining. What is that? In this zone. in this zone this function is continuous or not continuous, I need to check. What is this? Whenever x equal to a value is greater than 1. So we'll move to case 5, last case. We need these functions now, we'll carry forward with us. Case 5. I am checking the continuity of the function at x equal to a whenever a value is greater than 1. I am checking the continuity of the function at x equal to a when a is greater than 1. What is that fifth case? Whenever x value is greater than 1, how to check the continuity? Okay, how to check the continuity? Limit x approaches to a, f of x equal to f of a. Limit x approaches to a, f of x equal to f of a, then we say that this function is continuous at x equal to a. So to check the continuity of this function, first I'll calculate this one. Next I'll calculate this one. If both are equal, then I can say that function is continuous at x equal to a. Okay, limit x approaches to a, f of x. Okay, that equal to limit x approaches to a. What is the function? As x approaches to a and a value is greater than 1. When a value is greater than 1, function is what? Function is 2. Okay, so here function is 2. F of x is 2. Now I need to calculate this limit. How to calculate this limit? Wherever f of x is in direct method. How to calculate this? Direct method. In the given function, wherever x is there you write a. So here what is this? This is 2 only. So I calculated this, I got it as 2. Now I need to calculate f of a. Okay, I need to calculate f of a. What is a here? A is greater than 1. When a is greater than 1, f of x is what? 2. F of x is 2. F of a is also 2. Okay, f of a is 2. So what happened? I calculated this, I got it as 2. I calculated this, I got it as 2. Now I'll equate, that means these two are equal. Okay, so what happened here? Therefore when I got this statement, I can say that f of x is continuous at x equal to a as a is greater than 1. So in fifth case also this is continuous. I checked the continuity on its entire domain. You can check in case 1 it is continuous, in case 2 it is continuous, in case 3 it is continuous, case 4 continuous, case 5 is continuous. So there is no point of discontinuity. So I can say that f of x is continuous. I'll write here from case 1, case 2, case 3. I'll write therefore from case 1 comma case 2 comma case 3 comma case 4 comma case 5, from all these 5 cases, what I can say? F of x is continuous. F of x is continuous function. Okay, if you like this video, please drop a like for this video and share this video with your friends, and don't forget to subscribe to my channel. Thanks for watching. Take care. Bye bye.